Alright, let's continue with 2024 paper 3 question 1b. Okay, this question asks about relative reactivity from chlorine to iodine. Okay, so we actually just talked about the volatility in part A. Now they are asking you about reactivity. Okay, so the trend in reactivity can be determined by carrying out 3 experiments. Okay, so in each experiment, aqueous halide ion, like the Br minus, I minus, is added to a solution containing a halogen. Okay, so like Cl2, I2. For any experiment in table 1.1, predict the color of the final solution and write an equation for any table that occurs. Okay, so do take note, this is about reactivity. So they wanted to find out if you add the halide, right, will it displace the halogen, right? So, or will the halogen displace the halide? Okay, so this actually we need to take note. Number one, we need to predict the color of the final solution if there was a displacement. And number two, we need to write an equation. Okay, so if there's no reaction, we just need to state clearly. Okay, this last part is very important. They say explain your answer using E0 values. Okay, so we need to use the data booklet E0 values. Okay, in case by now you're still not very sure what this question is asking, this question is basically asking you to just use the E0 cell to predict whether a reaction will happen. So E0 cell is calculated by E0 reduction minus E0 oxidation. Okay, so we just need to go and find out the electrode potential from the data booklet. Okay, so let's take a look at the data booklet. Okay, so if we are adding Br minus to Cl2, right? Cl2 definitely is more reactive and will preferentially displace your Br minus, okay, and grab hold of the electrons. So Br minus will be discharged as Br2. Okay, so let me write down the equation, right, for experiment 1. So you're gonna have Br minus reacting with Cl2 to give you 2Cl minus and Br2. Okay, there should actually be a 2 here. Okay, so there's a transfer of electron from Br minus to Cl minus. Okay, so that will be the equation to answer number 2. Number 1, what is the color of the final solution? Just take note, for aqueous solution, Br2 is orange. Okay, so since we need to explain our answer using E0 value, we need to find those E0 value from the data booklet. So let's just take E cell equals to plus 1.36 volts minus plus 1.07. Okay, so 1.36 is the E0 for chlorine and 1.07 is the E0 for bromine. Okay, so you get actually a positive 0.54 volts. Okay, so a positive E0 cell means that this reaction is thermodynamically feasible. Okay, so this reaction is feasible. Okay, so that is for experiment 1. Let's now go to experiment 2. Again, we have a more reactive halogen, Cl2, will displace your I minus. Okay, so let's do experiment 2. So instead of Br, now we have 2I minus plus Cl2. That will give you 2Cl minus plus I2. Okay, what's the color of I2? I2 will be brown. Okay, aqueous iodine is brown in color, and so we need to calculate the E naught cell, show using E naught values, right? So the value from chlorine is the same. You minus off a positive 0.54. This actually gives you a slightly larger voltage, which will be 0.82 volts. Okay, which means that this reaction is also feasible. Okay, so that is for experiment 2. Okay, so for experiment 3, right, I2 is not gonna be able to displace Br minus because Br is more reactive compared to I2. Okay, so if you go and calculate, so this experiment 3, you just put no reaction. Okay, so show using the E naught cell, right? E cell equals to positive 0.54 minus positive 1.07. Okay, so that will give you a negative 0.53 volts. So it's not feasible. Okay, so that's it for the 3 reactions. Alright, so 5 marks in total just to do a couple of calculations. I think it is well worth it. You got to make sure that you answer all 3 parts, yeah? So the first part, if there's a reaction, predict the color. Orange, brown, the last one no reaction. Write down the equations, okay, written down, third one no reaction, okay. And the last thing you need to answer is to write down the E naught value from your data booklet. Okay, so we've covered all grounds. We should be able to score the whole 5 marks from part B.